So last time what we discussed was the general overview of the modular exponentiation, and in this video we'll be taking one example and applying that. So what we discussed in particular was that if we are given something like this, b raised power mod m, and if the numbers are bigger, to make it much more simpler, what we can do is that we can do the binary expansion of the n. We can do the binary expansion of n over here, and then the n, which is the power of b in this expression, would be something like this. And then we'll be using certain corollaries and make this entire calculation very easy. Now, it will be more clear with an example. Let's take an example of 3 raised power 644 mod 645. And we have to calculate its value, which should be equal to 36. Now, in this case, n is equal to 644, and let's do the binary expansion. Therefore, b will be equal to 2 in this case. So we have to represent 644 in terms of the powers of 2. So the best way to do is we'll express 644 in terms of the powers of 2, and one way is to continuously divide 644 by 2 and then looking at the remainders. This is what we did if a number is given to us in its decimal form, and how we convert it into an octal form or the hexadecimal form or into the binary form. Now the other way we can do is, which I call as a shortcut way, what we do is we have this number, and if we have to convert this number into its a binary form, what we do is we keep on dividing them by 2. And when we keep on dividing them by 2, we ignore the remainders. So this is important. We ignore the remainders, and the value that we obtain for the even value that we obtain after the division, we represent that with 0, and for the odd value we represent it with the 1. And we ignore the remainder. So 644, if we divide it by 2, this will be 322. And then if we further divide it by 2, this will be 161. And now we further divide it by 2 by ignoring the remainder. This will be 80. And we further divide it by 2. This will be 40. We further divide it by 2. This will be 20. We further divide it by 2. This will be 10. And then we further divide it by 2. This will be 5. And if we further divide it by 2, this will be 2. And then if we further divide it by 2, this will be 1. So let me write it here. This will be 1. So this will be 1. Now instead of For even, we'll have 0, so this will be 0, this will be 0, this will be, since this is odd, this will be 1, this will be 0, this will be 0, this will be 0, this will be 0, this will be 1, this will be 0, and this will be 1. So let me write it here so that this becomes quite easy to see. 1, 0, 1, 1, 0, 0, 0, 0, 1, 0, 0. So this will be our binary result. Now the other thing that we have to do is, since we have to represent it with the n with the power of 2, then we look at the power associated with each digit in this string. So this will have a power of 0 associated with this. This will have a power of 1, this will have a power of 2, this will have a power of 3, this will have a power of 4, 5, 6, 7, 8, and 9. Since 1 means the presence and 0 means the absence, what we see here is that the numbers that are present is, let me change the color. So this is present, this is present, and this is present. So n will be equal to, n in this case will be equal to 2 raised power 9 plus 2 raised power 7 plus 2 raised power 2. Then this expression can be rewritten as 3 to the power of 2 raised power 9 plus 2 raised power 7 plus 2 raised power 2 mod 645. So then this can be again written in a different way. So this will be equal to 3 raised power 2 with the power of 9 times 3 with the power of 2 raised power 7 times 3 with the power of 2 raised power 2. So we know when bases are same, powers are added. So this and this is the same thing, and it will have mod 645 with it. Now using the corollary, using this corollary, we can again rewrite this as 3 raised power 2 with the power of 9 mod 645 times 3 with the power of 2 raised power 7 mod 645 times 3 with the power of 2 raised power 2 mod 645, and this entire thing will have a mod 5, mod 645 outside. Now All of this will become easy if we know the value of this, if we know the value of this, and we know the value of this, then we do the mod of 645. So basically we divide it with 645, so what will be the remainder? That will be the value. Now, doing it this way might be quite cumbersome if you are, especially if you want to do it with paper and pencil. That kind of calculation may not be easy. So the best way is that we start small. First, we need to know the value of the smallest value, which is in this case 3 raised power 2 raised power 1 mod 645. And then you keep on calculating and using this, you calculate 3 raised power 2 raised power 2 mod 645, so on till you find the last one, which is 3 raised power 2 with the power of 9 mod 645. So let's first start with this basic one, which is 3 raised power 3 with the power of 2 raised power 1 mod 645. So this one will be equal to 3 raised power 2 with the power of 1 mod 645 is the same as 3 times 3 mod 645. So this will be equal to 9 mod 645. And the value will be 9, since 9 is less than 645, therefore the remainder will be 9. Then let's set our eyes on 3 raised power 2 raised power 2. Mod 645. That will be the same thing as 3 2 times 2 mod 645, which will be equal to 3 with the power of 2 whole square mod 645. Now, using the same corollary, which is 3 with the power of 2 mod 645. So if you expand this using that corollary, this will be equal to this times this, and then the whole thing will have mod 645 at the end. So we know from the previous calculation that this value and this value, that's this value and this value, is equal to 9. So we'll substitute that. So this will become 9 times 9 mod 645. So this will be equal to 81 mod 645. And again, this value, since 81 is less than 645, therefore this value will be 81. Similarly, let's calculate 3 raised power 2 with the power of 3 mod 645. So that will be equal to, that will be actually equal to 3 raised power 2 with the power of 2 whole square mod 645. So again, this can be written as 3 2 with the power of 2 mod 645 times 3 with the power of 2 raised to power 2 mod 645, and this entire thing has mod 645 at the end. So this value will be equal to, we know from the previous calculation that this was equal to 81. So this is 81 times 81. So this will be equal to 81 times 81 mod 645. So this will be equal to, if you do the calculation, this will be 81 square mod 645 will give you the value of 111. Similarly, we keep on repeating this process. Now, one more point worth noting here is that if you are confused here, like how is 2 raised power 3, 3 with the power of 2 raised power 3 equal to the square of this? Now we know the bases are same, powers are added. If you take 3 raised power 2 with the power of 3, this is equal to 3 raised power 8. Similarly, if you take the square of 3 raised power, or in other words, if you do the 3 raised power 2 raised power 2 times, which we are doing here, times 3 raised power 2 raised power 2, it's equal to 3 raised power, since the bases are same, powers are added, 2 raised power 2 plus 2 with the 2 raised power 2. So this will be equal to 3. The first one will be 2 raised power 2 is 4. Second one will be similarly 4. So this will be 3 raised power 8. So that's how this and this and this, they are all the same. Now let's move forward. Using this, we'll be obtaining 3 raised power 2 with the power of 4, and we'll get mod 3 raised power 2 raised power 4 mod 645 will be equal to 111 square mod 645, and the value that we'll obtain is 66. Then again, if we do 3 raised power 2 raised power 5 mod 645, will be again using this one in this. So since it will give us 66 previously, this will be 66 square mod 645, and this value will be equal to 486. Similarly, 3 with the power of 2 raised power 6 mod 645 will be equal to 486 square mod 645, and the value that we'll get is 126. So we'll be using it in the next calculation, which is 3 raised power 2 raised power 7 mod 645. This will be equal to 126 square mod 645. What we'll be getting is 396. Then again, we'll calculate 3 raised power 2 raised power 8 mod 645. This will be equal to 396 square mod 645, and the result that we'll be getting is 81. Then the last one, which is 3 raised power 2 raised power 9 mod 645, is equal to 81 square mod 645, the result that we'll be getting is 111. Now we needed three terms in particular, which is 3 raised power 2 raised power 9, 3 raised power 2 raised power 7, 3 raised power 2 raised power 2. And we have their values. So we have the values of, we have this value, we have this value, and we have this value. All we have to do is mod that with 645. Then let's check. 3 raised power 2 raised power 9 is 111. So this will be equal to 111 times. The second one was 3 raised power 2 raised power 7 mod 645. It's 396. And then we have 3 raised power 2 raised power 2. The value that we have here is 81. So we needed this one. We needed this one. And we needed this one. 81 times mod 645. So basically what we did is we were actually finding the value of this, this, and this is what we obtained. Now if you do the calculation, this entire thing will give you the mod of 36. And that's what we wanted to calculate. That's what we were supposed to calculate. And 36 is the answer. And we followed it by basically doing the binary expansion of n and then calculating the values of 3 raised power 2 raised power 1 all the way up to 3 raised power 2 raised power 9 mod 645, and then that gave us this result. So that was all. Thank you.